Alright, so welcome to the second video in the AMC 10 problem solving series, and we'll be solving a select problems from the Art of Problem Solving Volume 1 book. And we're going to start off with problem number 7 today, which asks us to simplify the above fraction. The square root of 2 over the square root of 2 plus the root of 3 minus the root of 5. Now immediately, one of the things you notice with this fraction is that instead of most rationalizing the denominator questions, which have two terms in the denominator, this fraction, has three terms in the denominator. Root of 2, root of 3, and negative root of 5. Now the reason we always like to have two terms is so that we can simplify the fraction using a mathematical property known as the difference of squares. Now, how does this property help us to simplify fractions which have radicals in their denominators? Well, the difference of squares is when you have the product of two terms, a plus b and a minus b, and their product will be a squared minus b squared. Now what happens is that these opposite signs, plus and minus, help to eliminate any middle terms within this expression. For example, when you have a plus b squared, you'll instead have a squared plus 2ab plus b squared. This middle term hangs in the balance. But with these opposite signs, you don't have any middle terms. And when we rationalize denominators with two terms, with two numbers or variables, we use that to our advantage as follows. For example, if you have this fraction, 1 over 3 minus the root of 2, we're going to multiply it by its conjugate. And its conjugate will look the exact same, except it will have the opposite sign. Instead of minus square root of 2, it will have plus square root of 2. And as you'll see, what we're going to be left with is, on the numerator, we'll have 3 plus the square root of 2. And in the denominator, we're going to have 3 squared, which is 9, minus square root of 2 squared, which is 2. And now we don't have any more radicals. Now, the problem with this question is that here we have three terms. So how can we possibly solve this problem? Well, one of the ways you can solve it is treat three terms like 2. How? Well, one of the ways we can do that is by treating the first two terms as a single term. And we're going to do that by using parentheses. So we're going to write parentheses, the square root of 2 plus the square root of 3 minus the square root of 5. And we're going to multiply that by its conjugate. Now remember, the conjugate will always have the opposite sign for the second term, which in this case is the third term. So we're going to write root of 2 plus the root of 3 plus the root of 5. And just copy that for the numerator. Now, at this point it's just a matter of simplification, right? We're going to have the square root of 2 multiplied by this whole thing, which is the square root of 2 plus the square root of 3 plus the square root of 5 all over. Now, are we actually going to FOIL this out? No, because we can use the difference of squares to our advantage. We square the first term, which is the square root of 2 plus the square root of 3, minus, we're going to square the second term, which in this case is the third term, because we grouped the first two terms together as a single term. Okay, now let's just evaluate this. Root of 2 gives us 2 because it's the square root of 2 squared. Root of 2, root of 3, 2 times 3 is the root of 6. Root of 2, root of 5 gives us root of 10. We're going to divide that by, now be careful here, we're not just going to cancel out the square and square roots for the first term. Instead, we have to use the binomial theorem and expand this out as follows. Remember, the binomial theorem states that if you have term a plus b squared we're going to have to rewrite this as a squared plus 2ab plus b squared. Now you're going to apply the same principle for this denominator. The square root of 2 squared plus 2a, which is the square root of 2, times b, which is the square root of 3, plus b squared, which is the square root of 3 squared. And don't forget to pluck on that minus square root of 5 squared. And from here on, it's going to become much easier. You're going to have this square and square root cancel out, this one cancel out, this one cancel out. And what you're going to be left with is, hopefully you can still see that. Yep, you can. Okay, so what we're going to be left with at this point is 2 plus the square root of 6 plus the square root of 10 over 2, disregard this, 2 square root of 6 plus 5 minus 5. Of course, this turns out to be 0, so we're not going to bother writing that at all. Now, this problem is something in familiar territory, right? Now we can solve this problem as we always do. Multiply this by root of 6, multiply this by root of 6. We multiply this denominator by the root of 6 so that this square root of 6 becomes a square, and the square and square root cancel out. So we're going to multiply this whole expression by the square root of 6. And this is going to be 2 square root of 6 squared, which is, of course, 2 times 6, which is 12. Now, we're going to simplify this out. We're going to see that 2 times the square root of 6 is 2 root 6 plus the square root of 6 squared is, of course, 6 plus the square root of 60, because 6 times 10 is 60. Divide that by 12. Now this is just a matter of simplification, right? This square root of 60 is going to instead becomes the square root of 4 times the square root of 15. And the square root of 4, of course, is just 2. So we're going to end up having, let's factor out the 2 so we can simplify even more. So we have 2 root of 6 plus 3 plus root of 15, all divided by 12. Okay, now we're going to finish simplifying this. 12 divided by 2 is 6. So we're going to end up with our final answer being the square root of 6 plus 3 plus the square root of 15, all divided by 6. And that is the answer to the first question. Now, let's tackle the second. The second question asks us, find x if 2 raised to 16 raised to x is equal to 16 raised to 2 raised to x. Now this seems like a loaded question, but let's tackle it carefully and find out. So we have 2 raised to 16 raised to x is equal to 16 raised to 2 raised to x. First thing we always want to do in these exponent equation problems is set the bases equal to each other. Now how do we do that? Simple in this case. 2 to the 16x is equal to, now notice that 16 is a power of 2. So this problem seems to be pretty easy. 2, so we're going to write 16 as a power of 2 and multiply that by 2x. Now we seem to be done. Let's just put the parentheses right here. So now you see that we have the same base, which is 2, in both sides of the equation, and now we can set up the exponents equal to each other. Now at this point you realize that the rabbit hole goes even deeper. It's an exponent problem within an exponent problem. So you have 16 raised to the x is equal to 4 times 2 to the x. Now the good thing about this problem is that you see everything is a power of 2. 16 is a power of 2. 4 is a power of 2. And of course 2 raised to the x is expressed as a power of 2. Now, we just need to use our rules of exponents very carefully, right? So we're going to write this as 2 times 4x is equal to, since we're multiplying exponents which have the same basis, we're going to add the exponents. So that we have 2 raised to 2 plus x. Now, this is going to turn out to be 4x is equal to 2 plus x. Remember, since we now have the same basis and everything is simplified, we're going to set the exponents equal to each other. So we're going to subtract x from both sides. We're going to get 3x is equal to 2. And now we're going to end up... Oh, wait, what? wait. We're going to have 3x is equal to 2. And x is equal to 2/3. And that is the answer for the second question. Now let's move on to the third question. Now I'm going to speak out this question because it seems to be written way too small. Okay, so this question asks us, show that if a and c are positive integers where a is not equal to c, that a to the x power is equal to c to the q. And okay, so this is part of the given information that the problem provides us. A to the x is equal to c to the q, and c to the y is equal to a to the z. Then x times y is equal to a times z. So this is the information we are given. And this is the question we're asked to find. We're supposed to show that the product of x and y is equal to the product of a and z, which are the exponents. So how can we go about solving this problem? Well, one of the things we can do is, well, let's first write out the exponents which have the same basis on the same sides. So I can write a to the z is equal to c to the y. Now what that allows me to do is, well, you can see that right away we can form some sort of a system, aka in this problem we can form a proportion. Now we can write a to the x times c to the y is equal to a to the z times c to the q. Now you notice that this x and z corresponds to each other. Therefore, x is equal to z. This y corresponds to this q. So therefore, y is equal to q. And thus, if we multiply x times y, its product will be equal to z times q. And thus, is that what the question asked? Oh wait, z times q. Oh, sorry, this is supposed to be a. Wait, no. Is equals to z. I might have written the question wrong. Oh yes, this is q, not a. This is q. And thus, we solved the problem. We showed that the product of x and y is equal to